Today's video can be found on page 41 in your packets. It's a problem of the day page, and there's a couple notes here. The first thing that you need to do in this string of integer addition and subtraction is to change all the subtraction to add the opposite. Then I like to add like all the negatives together, put those together, and then add all the positives together and last do it. But you can choose. But you do have to follow this rule here, change all the subtracting to adding the opposite. Next page. Distance between two rational numbers on a number line. So I'm going to work through some of these and leave some of them for you to do. Use the number line to answer each of the following. What is the distance between -4 and +5? Well, -4 and +5, 1, 2, 3, 4, 5, 6, 7, 8, 9. Their distance is 9 units. They're 9 units away from each other, making the little hops. Person B says, what is the distance between +5 and -4? Well, it's the same two numbers, and it doesn't matter if I go from left to right or right to left, I'm still going to get 9 units. What is the distance between -5 and -3? Well, they're very close. Here's -5 and -3. They're only 2 units apart. What is the distance between -3 and -5? Again, commutative, I'm still going to get that they are 2 units apart. You don't have to draw the little waves there, the little hops, if you don't want to. What is the distance between 7 and -1? 7 and -1. Well, I know that I'm going to have to go down 7 to 0 and then 1 more to get to -1, so I know that's 8. What is the distance between -1 and 7? Again, it doesn't matter if I do them in the opposite order, because really I'm just counting how many units there are. So here I would go up 1 to 0 and then up 7 more. So I could do this, and then up 7 more. I could draw an arrow, and yes, I would get 8. So I'm going to ask you to do exercise 2, parts A, B, and C. So go ahead and do these. Pause the video, put the dots on the number line, the points, where the points are, and then tell me the distance between those two integers. So hopefully you finished the bottom of page 42. There's a formula that you can use if you're not given a number line to find the distance between two rational numbers. Find the distance between -3 and 2. The steps are to, start on -3 and count the units up to 2. So again, 1, 2, 3, 4, 5. I'm going to get 5, that those numbers are 5 units apart. The formula way of doing it is to take the absolute value. So for the two rational numbers P and Q, okay, they're -3 and 2. Q is 2. The distance between them is the absolute value of their difference. See the subtraction sign here? So I would do -3, and it's different by 2, or its distance. Difference means subtract. So, and this is a subtraction problem, so the first thing I would do is change it to keep, add, up. Keep, add, and that's a +2. Yes, this is +2 here. So adding the opposite of that would make it -2. And I'm keeping the absolute value symbol because I'm doing what's inside there first. So same signs, add and keep. Yes, I'm going to get -5. But what's the absolute value of -5? It's 5. So a little more tedious if you don't have the number line to find the distance or the difference between -3 and 2. Distance is positive. Well, distance really doesn't have a sign. Change in elevation or temperature may be positive or negative depending on whether it's increasing or decreasing, going up or down. A hiker starts at the beginning of a trail at a point which is 200 feet below sea level. So, I'm going to draw a little drawing here. 200 feet below sea level, so he's down here somewhere at 200 feet below that sea level. And he hikes to a location on the trail that is now 580 feet above. So he's hiking on a trail, maybe the trail's kind of windy, and he gets up here to 580 feet above sea level. Okay, he was below sea level, now he's above sea level. What is the vertical distance between 200 feet below sea level and 580 feet above sea level? So 200, that's negative 200, and its distance, the difference of 580, right? So if I take that absolute value, I'm going to get negative 200 plus a negative 580, which I know its absolute value would be same signs, add and keep. I would get negative 780, but distance isn't negative. It's going to be 780 feet. And yes, I could see that in my little picture that I drew here. I would need to go up 200 feet just to get to sea level, right? And then another 580 feet to get up to the top of the trail where they ended. So yes, 200 plus 580 gives me that 780 feet. How should we interpret that 780 feet in context of the problem? Well, the hiker traveled. He didn't, go a positive or a negative. The hiker traveled or hiked a total, leave a little space there, not at, a total of 780 feet. Or the hiker's hike was 780 feet in the context of the problem. You have to say something about the hiker. After lunch, the hiker hiked back down from the trail point of elevation. So he was up here at 580 feet. Now he's going to come back down to the beginning of the trail, which was 200 feet below sea level. Well, I know that distance didn't change, right? He's going to go down that 580 feet to get to 0, and then down another 200 feet to the bottom because he's at a point that's below sea level, like maybe he's in New Orleans or something. That city's below sea level. So what is the vertical distance? The vertical distance, the difference between them, I already know that, is 780 feet. What is his change in elevation? Also 780 feet. We went from a positive 580 to a negative 200. Next page. The distance between a negative number and a positive number is 12. What are the numbers? The distance between a negative number and a positive number. So it can't be 0, I know that, because that doesn't have a sign on it. But it could be like negative 11 and positive 1. Yeah, they're 12 apart from each other. Or it could be, 6 and negative 6. It could be negative 10 and positive 2, right? Could be negative 9 and positive 3. It could be negative 8 and positive 4. And there's lots of them. It could be and I could switch this. I could say it could be 9 and negative 3. And I could say it's 10 and negative 2. So all the things numbers that the add-ends that add to 12, right? 11 and 1, 6 and 6, 10 and 2, 9 and 3, 7s and 5s, 8s and 4s, right? And then just put the negative on the opposite numbers, right? So lots of them. They have to add to 12, right? Use the distance formula to find each answer. Support your answer using a number line diagram. Find the distance between negative 7 and negative 4. Okay, I have to use a number line. Use the distance formula and support your answer with a number line. Okay, so the distance formula, I would start with that, would be -7 minus -4, because it's the difference between the numbers. And of course, I would add the opposite, so that would be -7 plus a +4. The absolute value of that, different sign, subtract. Take the sign of the larger number. So 7 and 4 is going to give me 3. The absolute value of that is 3. So their distance is 3 units apart. If I have -7 and -4, barely going to get it on here. Okay, so -7 and -4, yes, I can see that it's only 1, 2, 3 hops away, that it's 3 units, right? Their distance is 3 units. Support your answer using the number line. I did that. Okay, so I'm going to leave for you to complete D, E, F, and G, and then I'm going to read the lesson summary. To find the distance between two rational numbers on a number line, you can count the number of units between the numbers. Yep, on a number line, count, hop, hop, hop. Use the formula of taking the difference, the absolute value of the difference of the numbers. Distance is always positive. Really, it doesn't have a sign on it, but it can't be negative. And change may be positive or negative. For instance, there is a -4 change when the temperature goes from 7 down to 3. But what's the distance between 7 and 3? 4. Okay, and that's it for today's video.